Hello, so if you can turn to page 34 of your packet, we're going to talk about inverse functions. Now, all an inverse function is it's a reflection over the line y equals x. So what that means is if you were graphing, okay, so I set up a little graph over here. If I had the point 4, 2, and I wanted to reflect that over the line y equals x, okay, so basically I would fold my graph along that line. I would wind up over here at the point 2, 4. Okay, so I would wind up over here at 2, 4. So what you notice is that when you reflect over the line y equals x, the x-coordinate now becomes the y, and the y-coordinate now becomes the x. So what we're going to do is we are going to find the inverse, but given equations instead of giving a graph. But it's really the same thing, okay? If you're given an equation, see how this equation has a y and an x? All you do is your y becomes the x, and the x becomes the y. So all you're really doing is swapping the x and y variables within the equation. Okay, so all of that may sound a little confusing, so let's do an example so we can see. Okay, so number 63 says, what is the inverse of the function y equals 4x plus 5? Well, to find an inverse, what we do is step one, we swap the x and y variables. So I'm going to change this y to an x, and I'm going to change this x to a y. So now it'll say 4y plus 5. Okay, and then step two is we're going to solve for y. So we're going to get the y by itself in this equation. So if you wanted to solve for y, I would first subtract the 5. Which leaves me with, on the left-hand side of the equation, x minus 5, and on the right side of the equation, 4y. Okay, now from this point, to get the y by itself, we are going to just divide both sides of the equation by 4. Okay, so that leaves me with y equals. Now I'm looking at the answer choices, and I don't see an answer choice that looks like this. So it looks like what they did was, let's think about a 1 being in front of this x. It looks like they individually divided both terms in the numerator by 4. So here we would have a 1x over 4, which we could write as 1/4 x. And then minus a 5 over 4. Okay, and we could see that choice 2 matches up with our equation here. Okay, let's look to the next page, page 35, and let's look at number 66 right on top. Okay, so now number 66, they want to know what is the inverse of the function f of x equals this. Now, I want you to notice with the answer choices, see this little symbol right here? This little symbol means inverse, so I'm going to put that up here, okay? The inverse, you write as f inverse. It almost looks like an exponent of -1, right? That's how we write the inverse. Okay, now if you recall, when we want to find the inverse, we swap the x and y variables. Now, technically I don't see a y here, right? But doesn't f of x, doesn't that mean the same thing as y equals? So what we're going to do is we're going to switch this y to an x, and we're going to switch this x to a y. Okay, so again, to start, all we did was we switched the y, f of x means y, to an x, and the x to a y. And remember, step 2 is to solve for y. Let's get y by itself in this equation. All right, so I'm first going to add the 3/2 to both sides of the equation. All right, so that's going to leave me with x plus 3/2 equals 1/2 y, right? Because these cancel. Now, technically you could divide both sides of the equation by 1/2, but why have fractions within fractions, right? So instead of dividing by 1/2, isn't that the same as multiplying by the reciprocal of 1/2, which is 2 over 1? Okay, and the reason we would do that is because then the 1 on top would cancel with the 1 on bottom, 2 on top will cancel with the 2 on bottom, leaving us with just a y. But if we multiply this side of the equation by 2 over 1, we have to also multiply the left side of the equation by 2, or 2 over 1. Okay, so if we distribute 2 over 1 times x is just 2x, and then 2 over 1 times 3 over 2 would be, well, if I were to multiply these two fractions, you could do it one of two ways. You can multiply the numerator, so 2 times 3 is 6, and 1 times 2 is 2, so 6 over 2 simplifies to 3. Or you could just say, you know what, doesn't this 2 on top cancel with the 2 on bottom, right, like this? Leaving me with just a 3 over 1. So either way, we're going to have plus 3. Now, since this started in function notation as f of x, we need to change this back to function notation, but I'm not going to write f of x. Doesn't this represent the inverse, right? And didn't we say this is the symbol we use for the inverse? So I can rewrite this. I'm going to do it over here as f inverse of x equals 2x plus 3, which matches up with choice 1. Okay, so the last one we're going to do today, if you can flip to page 37, we're going to do the one on top of that page, number 72. Okay, so again, what is the inverse? So technically, we know this is a fancy way of saying y equals, so we're going to switch that y to an x. And we're going to switch both of these x's to y's. Okay, so now we need to get y by itself in this equation. And that's going to be tricky because we have two of them. Okay, so I would start this one of two ways, but either way, it's going to lead you to the same exact answer. You can either put this x over 1, and you can cross multiply to solve. So you can do y times 1, which is y, and then we can multiply the x by the y plus 2, which would give us, actually, let me write it out like this for right now, x times y plus 2. That's called cross multiplication. The other way you could have started this, I'll show you over here. If we did, I'm going to go back to the original equation. If you want to get rid of this denominator, you can just multiply both equations by y plus 2. So this y plus 2 on top will cancel with the y plus 2 on bottom, leaving us with just y, which, look at that, that's what we have here. And you'd be multiplying the x by the y plus 2, which is what you have here. So whether you think about it as cross multiplication or just multiplying by the denominator, it's the same exact thing. Okay, I'm going to get rid of this because this is just kind of making a mess. All right, so let's solve. So now to solve this, I would first distribute the x. So that's going to leave me with y equals x, y plus 2x. All right, now if we're solving for y, we have y's on both sides of the equation. We want to get them all to one side of the equation. So maybe I'll move this term over here. So I'm going to subtract xy from both sides of the equation. All right, so on the right side, I'm left with 2x. On the left side, well, x minus xy, these are not like terms. I'm sorry, y minus xy, these are not like terms. So I'm just going to have to leave it as I see it, y minus xy. Okay, so let me give myself a little more room. Actually, look at this, I'm running out of room. You know what I'm going to do? I'm going to rewrite this up over here. So we have y minus xy equals 2x. Now, if I want to solve for y, right, I need to get y out of both of these two terms. So I'm just going to factor out the greatest common factor, right? Can I factor a y out of both of these two terms? So if I factor out a y, in parentheses, that's going to leave me with 1 minus x. Okay, so all I did was took out the greatest common factor. All right, and then let me bring down this. So to get the y all by itself, I'm going to divide both sides of the equation by what it's being multiplied by the 1 minus x. All right, so that leaves me with, now, since I have y by itself, right, since this was in function form, I might as well change it back to the inverse notation now. So f inverse of x equals, now, I do not see this answer there. I see choice 1 has a 2x on top, but this says x minus 1, which means you have a positive x and a negative 1. We don't have a positive x and a negative 1. We have the opposite. We have a negative x and a positive 1. So choice 1 is definitely not our answer. All right, let's see if we can maybe maneuver this around a little bit to get it to look like one of these other answer choices. Now, let's think about this. There's a couple of different ways you could think about this, but this might be the easiest. Aren't you allowed to multiply the numerator of our equation by whatever you want, as long as you multiply the denominator of the equation by that same thing? So I'm looking at choice 2. See how that says negative 2x? What if I multiply the top of this by negative 1 and the bottom by negative 1? Then what's going to happen is 2x times negative 1 would be negative 2x. And I'm going to reverse the order of this to match this. Negative 1 times 1 would be negative 1, right, if I'm distributing. And then negative 1 times negative x would be a positive x, which I'm going to put that positive x in front of it. Okay, I have a negative 1 and a positive x. So look at this. I was able to get that to match up with choice 2. So this one was really tricky because not only, was there two y's in there and you had to factor them out and divide, but then you had to manipulate your answer to get it to look like one of the answer choices. So that was pretty tricky.